Hola, buenas tardes.
Hello, good evening. Thank you for the introduction. Thank you, INCIBE, for inviting me to be here today, and for all of those of you who have stayed for this workshop, which I hope is going to be interesting. I don't know if you are very experienced in answering to incidents and to detecting issues. I'm going to try to make this as practical as possible. I'm going to show you a few examples, but of course it's going to be a short introduction. Well, first of all, my name is Javier Marcos. I work in cybersecurity. I've worked in cybersecurity for the last 15 days. I am a systems engineer and security engineer. I love open source software, and I have worked for Facebook, Google, Airbnb, and now I'm working with cryptocurrencies. And well, I have always been really close to open source community, and I have always tried to contribute with projects that I thought could be interesting from the point of view of security, but also because technological companies do support open source. And so there is a project that I was lucky enough to take part in. I don't know if you've ever heard of Osctrl? No one? Well, better so, because that way I can introduce it to you. Well, I'm going to start talking about how this workshop is going to be structured. First of all, I'm going to tell you about Osctrl, what the concept behind it is, how it came up. It was a tool that was created at Facebook at around mid-2015, and well, I will tell you about it in a minute, but I'm going to tell you about the basic concept, how we use that, and then related information that we're then going to use in order to use Osctrl in a scalable environment of hundreds and even millions of machines, because in these cases what you really want is to be able to manage OS gathering and information generation of all the machines that you have in your production environments. And when it comes to technological companies such as Facebook or Uber or Google, the number of production machines even within the company is enormous. We can even talk about millions of servers. So I'm just going to explain how the concept of Osctrl applies in this kind of environment, how it can be used, how it can be implemented, and finally how you could manage those nodes or those agents that are within your corporate production system, and how you can manage them with Osctrl, which is the tool that I have developed myself. This is the third iteration of a tool that I started developing in 2016. It was successfully deployed in a corporate environment at Uber, and I think right now it counts around 500,000 machines, Windows, Mac, Linux, and all of that sort. Still working, and I'm actually quite proud that although I'm not working at the company anymore, that they're still using my software. That was the first iteration. Then there was a second iteration, which was what I then converted to Osctrl, and this is open source, so you can use it at home if you want to improve your detection infrastructure or just recollect, gather logs, etc. So I'm just going to show you the tools components, how the logs are gathered, and how you can then use it yourself. So Osctrl. First of all, right now, the companies that use Osctrl to collect or gather logs is actually quite big. You can see many names here, and there are also other companies that do not want to be acknowledged publicly, but there are really, really big companies. And actually, Google has recently done an integration with Osctrl and their forensic artifacts recollection tool, CRRS. And you can see here an example of all the companies which are using Osctrl and who don't mind people knowing. Obviously, Facebook uses OSQuery in all their systems, even network appliances, and all the others as well. So you get an idea more or less of what the impact of a tool that was developed by 3 people, the engineers in this project, and which is now being used in very important production systems. So the idea behind OSQuery is to expose your operating system using SQL extraction. So the idea behind using this extraction with SQL was to create a system that generated abstract data in different infrastructures, and it was able to detect intrusion or to detect incidents as well. So if you can detect that, then it is very important to have early detection so that you can then issue a response really quickly. Now, OSQuery uses 100% OS API. So all the tables I'm going to show you later will be native code from the operating system of every platform that supports OSQuery. For example, if you want to know the amount of processes that are going on in a Linux system, it's going to show you a list, but it's not going to parse those PS or any other thing that usually takes place in system administration to see commands and how machines work, and then you have to parse everything. So OSQuery wants to bring normalized data that can be applied to all the platforms that are supported by it. So osquery.io is where you can find information about the different packages that you can download, see the different versions, the tables, and the GitHub repository on OSQuery Foundation used to be under Facebook's open source account originally, but now, a few months ago, it happened to be it changed to an organization of the Linux Foundation, so that there was no way of affecting the decisions that could be made, because obviously the project was at the inception created on Facebook, but it has a very wide impact in this industry right now. So there's a committee which is currently making decisions about where the code is added to and where attention needs to be drawn. Now, the motivation behind OSQuery was, other than detecting intruders and generating logs, was basically, would you be able to just picture this in your corporate environment, which in this case we're saying portable Linux or Mac and Microsoft computers, laptops. How many of these have an extension with the identifier? How would you be able to retrieve that information? How many file descriptors were opened yesterday in the production environment every hour? Or, for example, if you have a full bridge VPN in your corporate network, is there a system that is routing that VPN to your local network? How would you check that? You need to have very high capacity for executing commands, and then parse those commands, and then know exactly whether the information that you're gathering does or not make sense. So these are 3 examples which are quite visual, easy to visualize, and to understand the motivation behind something like OSQuery. So the first concept I would like to introduce within OSQuery is OSQuery I, which is an interactive shell, which is basically the CLI where you can execute your queries. And the idea behind this tool is to be able to execute these commands in a local machine to say, for example, you need to know which users or which processes are using UID 0, for example. So you would just try to extract the query within this system, and then you would be able to see which query you would need to execute and what outcome that query is going to give. So, for example, OS query has very good documentation. You can find almost any answer you're looking for on the wiki, and there's a very complete introduction because you've got flags and parameters and everything. And I'm just going to show you a little bit how this works so that we can keep on going with the explanation. By the way, if you have any questions, do not hesitate to interrupt me. If you need me to explain anything again, just let me know, and I will go back and try and explain it.
The question is that if there are consultations that are executed in OS Query, you need to have something installed. No, you just need OS Query. I'll tell you for each platform how it works because I'm working on several different platforms. Here they are. If you want to use it for Mac, you can install it with Brew, or in Windows you've got Choco. You can use APT Linux, or for distributions of the kind, you need an RPM with this command, and with FreeBSD, it also gets its own installer as well. This would be the place to start from. If you're using your computer, then you can install OS Query. So we have the different packages of the different architectures. Around a week ago, we found that if you had Linux 4.1, the 401 came out several months later. So the 401 version got stuck and it became stable and has this fault. So if you do your bin in the repository, then you need to go to the 402 version. You can see an example of how to get the PID, UID, and name. The core concepts that we have in OS Query are platform agnostic. We seem to have some issues with the sound. Can you hear me now? Yeah? So the basic concepts in SQL are platform agnostic. The PID, the name, and the UID from processes are basically the same in all platforms that use OS Query. And the option of using SQL is a technology that has been working for a long time, and most system administrators are familiar with that. So the SQL concepts tend to be well known. And you will be able to see how to do consultations using parameters or join the tables, as developers, system developers are familiar with. Let's take a look at an example here. So the main concept is tables, and is executed in each operating system, and we're going to get the information here. And this is the concept table from which you take some attributes. That is the columns that you'd like to take from the table. You apply some filters or some constraints. For example, I'd like the PID, the name, and the UID from the processes. where the UID is different to 0. And furthermore, the power of that is that you can join different tables and decorate the table with the different processes using a join on the UID. So you obtain more information rather than just showing the processes. Otherwise, you would have to do several different commands. You would have to do a pipe from one command to another, greps, and other things that we have to do usually to get this kind of information. The most basic command is .help, and this will give you basically the ideas. And the .help is taken from the SQL motor, so SQL Elite. It's SQL Elite 3 point something. I don't know which the most recent one is. So it's OSQL Elite in this case. The .table will give you all the information on the different machines that are running at the time. If you're using Mac and you use .tables, then you'll see everything that is connected to those platform. But if you're using a Windows, it will show you different tables because others depend on different platforms and others do not, so the information will be different. The command pragma table info in this particular case will give you the syntaxis or the columns within the scheme of a table. You will need this in order to do joins between tables, or if you needed to use a parameter within a table and you need to compare one with another. So this is quite useful. It's equivalent to a desk in an SQL. And this comes in the scheme of the tables. The latest version of OS queries 4.0.3, but it's not stable. The most recent stable one is 0.2. There are 4 different platforms that can be used. It's OS X, Windows, Linux, 4 different packets, and FreeBSD. The information can be easily collected, and it's easy to do joins and so on. The format of the tables in the scheme, so you can take a look at them. So these are some of the tables that generally give us quite a good deal of information when you need to respond to incidents or you need to extract information from a machine that might have been compromised. You can get a great deal of interesting information and to check the status of the machines that you're working with. An interesting point is that when you select a table, the code is executed each time you do a select. So that code is for each table, so it always executes every time you launch the table. There's a little detail to keep in mind here. If you understand how OS query works, then based on the nature of the data that you're going to generate or the complexity or the quantity of information that is being used, then there are different caches within OS query within its own process, so that you don't execute tables all the time, so that you don't have to execute them all the time. So if you want to see if the hard disk on a computer has been encrypted, then that information will be cached. And you see the changes in the system, then it's going to detect that for you. So that's done internally. If you need to get into further detail regarding whether or not there is cache in the table, then you're probably doing an advanced use of OS query and you'll know what you need. In this case, the time table, if you select date time, you click on command and it executes once again. We've talked about simple tables, and now we'll talk about tables with parameters. In SQL, this is a where, and you put in a parameter to compare with. In this particular case, it's a file. So we have the file table to extract information from files. You would extract the directory of the file where the path is, etc., issue, as you can see on the screen there, because this is what you have selected and this is what you've asked for. These are just the parameters of the consultation. Another example, which is very useful, is this one. You can use the file table to extract information from a file, but in this case, it's doing a join with the hash table, so you can extract the information from the table that you're pointing towards. It would give you the MD5 of that table. The hash table, you will see it will have MD5, 510, and so many different hashes. These are some examples for system administration. Could be on Windows or Linux. There are interesting tables, and they might be interesting for a systems administrator. You can look at the status, the number of users, which are the kernel modules, and what are the startup items that have been configured in a Windows system. An important point when you begin OS query is to understand the files. Once you've installed this on your machine, you need to know the default routes for OS query. So for Linux, through a deb or an RPM, here you have stroke etc stroke OS query, and then you have the configuration that would try to load all the flash, and I'll talk a little bit more about this in a minute. So we have stroke var stroke log stroke OS query. This would generate the logs. If you use a local logger, and then we have the bins and the OS query I, OS query D, and we'll talk a little bit about the packs in a moment. There's sets of consultations so that you can read as if it were an antivirus. It searches for very interesting information. So, as I mentioned before, it would be the same in these Mac systems. It would be installed with the brew. These are signed packages, and the difference is stroke OS query. It's var stroke OS query, the same for the logs, for the bins and the packs and so on. So these are just the default routes for the system. And last of all, those of you using Windows, there's an interesting point in that the first CV that came out, was for a range of privileges that in the router that was previously being used, because this was program data. Since this was not a system router, if you didn't have the right permission, then you could inject different extensions, and as a result, you would inject the permissions for OS query and install it as a system. The first one we had was for in a Windows system because it affected the roots. So now we have a little quiz to give you a couple of examples of consultations that you can use within OS query and that can give you interesting information. For example, how to get the host from the machine that is running. You'd do select host name from the system info table. Can you see anything? I'll make it a little bit bigger. Can you see it from the back? So I put in Osctrl I. I'll show you the table command. And these are all the tables that linked to this computer, which is a Mac. So if you put in this information, then you would get all the information from the system info table, and you'd get the different content. For example, we can do select host name from system info, and then you have the host. That's just one simple example. In this case, for the host, who would be the system users? It would be the users table. We would do exactly the same thing. It would be pragma info from the users table. Here you have the UID, the GID for the group, the shell, and so on. What do I want? The UID. So we would write in select UID, name from users, or rather username. And then you would get the user ID, the user, in this case, of the machine. And this is the process table, this last example. It's a little bit more complex. We show the processes table. And the scheme of this table is a little bit different because it has quite a lot of information. I would like information from the processes. I'd like the PID and the name, for example. And here you have the PID and the name. So now you might say, how would I know what the username and the shell of the user is, of the user that is running processes in the machine? Do you have any idea how you would do that? Well, you'd use a join from the users table and the processes table, and use that to extract the user shell and the username. So what does the user table show us? We've got the shell, and we write in select username. Since we're going to do a join, we need to put an identifier in for the table. So it would be u.username, u.shell from users. As you join processes, as P, where P.UID equals U.UID. And in this case, you would see the users that are running and the shell. This is where the use of the SQL comes in, and the join is done here. You can see how powerful this tool can be when you want to extract information from systems. And it can be quite a large quantity of information, especially if you have many machines. And in fact, in this case, they're not actually related to the platform. It would be the same in Linux, on Windows, and so on. It gives you the information directly related to the platform that you're using. So when you're getting infrastructure's information or information that you need to obtain. It's very useful. So do you have any questions so far? Either you haven't understood anything so far, or I've explained things very, very well. So let's go on. We've talked about OS query on my computer level, and I can execute consultations on my computer.
So how do I execute a query in 2000 computers? And especially if I want for it to extract the information continuously and send it somewhere else. So what you would use instead of OS query OS query YD, which is OS query's daemon. And the difference is how you launch the queries here. You install it as a service, as an init systemd launchd and Windows service. That's how you install it when you install the OS query package. It executes immediately and automatically, and I'm going to explain to you how you can configure it once it's installed and executed. What's powerful about OS query is that it executes queries continuously. And so the way the daemon works is that you program your queries to be executed every specific time frame. And you can configure that by seconds. And then you have the different types of logs that are generated, which are status and results. And status are generated depending on OS query status, whether there's been an error or a failure. And results, queries are the results of the queries precisely that you have generated through the programmed or on-demand queries. OS query YD flags are numerals. You have so many you couldn't even imagine. I'm just going to explain a few of them, the easiest ones. But as I was saying, Wiki is really good here, so just have a look on your own if you're interested in it. So the idea behind OS query daemon is that you have an operating system where you have processes, systems, users within that OS, and within this OS you would have OS query D running, and you would configure it with different flags and remote configurations. Then it would extract logs that would then be sent to centralized management, and within those logs is where you would apply the use cases for client infrastructure or detection infrastructure or whatever you want to use it for. So that if instead of knowing what commands users are executing, for example, you just want to monitor your CPU, the CPU of your production machines, you can do it. So you can see the flexibility that this tool gives. It's not just for security issues, but also for just system administration. So as I was saying, OS query D if you run the help, then you have a lot of flags, as you can see here, so you have more than enough to configure it. So these are very well documented on the wiki, and the way you can configure this flags, well, you actually have two options. You can either give the daemon through the flag file parameter, where what you're doing is just adding all the parameters you want line by line on a flag file, or you can just have JSON, a configuring file, and I'm going to show you both examples so you can then see them on Osctrl and see how this can be configured using flags and the different configurations or centralized configurations depending on what you want. And as I was saying, the help command is the same for OS query in general. It's the same command all the time. Now, the flag command that we've been seeing includes the flags that you can see on help, but on a file line by line. But what if you don't want to use a flag file and you just want to configure them through our configuration file? What you would do would be to take the name of the flag without the dash dash, then you would put it on a JSON within the options, and then you would have the configuration and the value. Historically, Osctrl, the way the JSON parser was implemented, it didn't matter whether you were using numbers, booleans, chains, anything, because it was going to interpret it anyway. On the 3.01 version, we changed that, and so the JSON parser changed from the C++ native version to rapid JSON, and that works much better because what we wanted to do was for the types to be well setted when they were generated, in the case that they were JSON types, because if you have something waiting for a string or a boolean, then the logistics might be a bit complicated if you want to access them. But this is just a little story, a little anecdote, because I've been, well, doing this for so long. Anyway, in this example, you can see here what we're doing is configuring the API file system, and you're taking it from the file system. This is the path, which is not the default path, because the default path is the one I showed you earlier in the different architectures. What we have here is the logger, which is where we're generating logs, and we would create log files locally in the system. And here on the splay field, what you are doing is to avoid CPU surges, and what you do is you apply a percentage of that splay to the programmed interaction. So what you're doing is saying if you have a 100-second interval and you're using 10% of splay, then you might, in the best of cases, it will be done in 90 seconds, and in the worst case scenario, it would be in 110 seconds. So you have a worst case and best case scenario. So if you didn't configure this, you get a 50%. So some people ask me sometimes, well, I've done this for 60 seconds and this is doing it whenever it wants. It's not that it's not working, it's that you have an splay. You could do an splay 0 and then it would execute it when you want it to be executed. But because Osctrl was originally thought to perform more than anything else and to work in systems where there are hundreds of machines, these little details do help you escalate the services that are running and have less performance issues. And this is just to have, for example, everything in UTC. When you have machines in different regions, if you don't want to use local times everywhere, you just use UTC and it's easier for everyone. So here we have another example. We've been talking about configuration, which is options, and now we're going to look into schedule, which is basically the scheduled queries that Osctrl is going to execute. And the format in this case would consist in defining the name of the query. You choose it. It has to be unique, because otherwise it would be executing the first in the configuration and not the next one if they had the same name. So here you have a chain, which is the query, which is where you execute in the console. Then you have the interval in seconds. And in this case, we're using 2, for example. There are more things that can be configured here within scheduled queries. You can define chain, you can define numeric for the interval in seconds. You can define the platform, because you might have a configuration where you are distributing information to different machines. Some queries are going to be executed in Linux because they're for Windows, and the other way around because they don't have the tables. So what you can do really is to limit the queries so that queries are only executed if they belong to a certain platform. And then we have sharding, for example, which is another configuration parameter. Say, for example, you have to work in a system with many machines, distributed systems, and a bit of load. So what sharding will do for you is to do a sampling of the queries that you're running. So it's not going to be executing them constantly, but just statistically and internally, without really talking to the other machines, is going to be executed in a percentage of time. Say you have a query with a sharding of 50% of hosts, and so what's going to happen is that 50% of the times it's not going to be executed. Say I have a query for every 30 seconds. If it hasn't happened in these 30 seconds, and it doesn't get executed, is because you have a shard for 50%. Now, this is a bit more complicated, but if you're interested in sharding, I think there was Blogspot that was created where they explain the concept of sharding and why it is useful when you have very distributed systems and have many different executions. And the last field that we have here is snapshot. And this is quite important because by default, with OS query, you are executed when you have the daemon configured, because when you are trying on your console, all the queries that are being executed are snapshot, which means they are always going to be executed. But when you have the daemon configured, you will not have snapshots unless you configure them to be so. When you have snapshots, they are always going to be executed, whatever it is. You will always get all the data. Otherwise, when you have the daemon running and you say, well, I want to get processes, you generate those processes and you ask it to give you the processes again. But if the query is not doing snapshot and no processes have been added or eliminated, then it's not going to show you anything because that data has already been generated. So if it hasn't changed, then you won't get data. And so when people say, well, I have configured it to extract some information, well, and I'm not getting anything, well, it's because nothing has changed, because OS query can know internally whether changes have been made since the last configuration. So as you can see, it's very powerful, but you have to take that into account because otherwise it might drive you crazy because you think that it's not giving you the users, but it's only because it hasn't changed. You could also choose to configure it so that you only get additions and not when something has been removed, or you can get everything, or you can just get a snapshot and then you will see everything. Now, what is sorry, there was a question? If you have, it keeps an internal status, like a hash, of the result of the execution, because SQL works with SQL Elite as engineering, but it's storing, it's ephemeral, and it uses RocksDB. That's from OS query. This is an ephemeral database in memory developed by Facebook based on Cassandra, and it has several optimizations, and that is what OS query uses in order to keep a register of queries and configuration and so on, because OS query is keeping a local configuration of its running status and of the tables that are being executed. And right now, the way it works internally has changed a lot, so I'm not very sure whether that has changed or not, but that is the way it used to work. And the question was, how does OS query know what the outcome is? I really don't know the detail. I don't know if it uses hashing or if it uses the outcome. I would need to look into it. Right. Anyway, so what I was saying is that if you configure the snapshots to be queries that generate a lot of information, you have to take into account that you're going to get a lot of information generated every time this gets executed. So if you want to know the processes all the time and you're going to be executing it for a long time, you're going to have a list of processes all the time. So you will have a lot of information. And that is where you need to take into account the information that is being generated, because this obviously takes up memory space. And when you execute osquery-d, if you execute the command and you look at the processes, you will see that some processes are osquery-d, and you have osquery engine and then the watchdog, which I will mention a bit further in the presentation. I'm going to tell you how Watchdog works. So we've talked about configuration options. We've talked about schedule for scheduled queries, where they are, the intervals. And now we're going to talk about another part of the configuration, which is the decorators, which is basically information that you add to the results of the queries that osquery is either storing or locally or sending to a remote system. And basically you can define the decorator can either be used only when osquery is loading, so that every time it starts, you execute that query because you need that information, and that information would be sent with the results logs that are being sent to a remote system. Or if you want for the decorator to be executed continuously, you would configure it as always. Now, this field is extremely interesting because when you have a remote osquery configuration and you have indexed data in Splunk, Kafka, Elasticsearch, whatever you use to store your logs, this is going to add metadata to all the information that you're indexing. So you won't need to run searches or to look for the information that the host is sending, but with a decorator you can see that this result comes from this host with a certain ID and etc. And I'm going to show you a few examples later. Another interesting concept about osquery is that when it was originally created, this is a little anecdote. We created the tool, we liberated it, we made it open source, we wanted for people to use it because it was very powerful, it did facilitate searches, but then people said, what do I do now with it? What queries should I send? Well, I don't know. What are you looking for if you're doing hunting? What do you need? What processes? What connections? Yeah, but do you not have queries for that? Well, I don't know what you're interested in. So anyway, what we had to do is to assess, have like query compilation with information that could potentially be interesting for different use cases. In this case, for example, we see that we have a pack, which is the files in the same format as the schedule field that we saw at configuration. So this is like adding a JSON block. So you have one to monitor the osquery process because you want to know whether this is affecting your machine's performance, for example, or queries which are interesting to incident response, such as compliance, malware, adware, known for Mac. We don't really have that much information about that sort of compilations. But in this way, you have a few. The same thing for Windows, have run queries to see if a machine is secure or not. And these are installed by default when you install osquery in your machine. So if you look for these files, for example, attacks.conf, you will see, if you look for that in the machine, you will see that you've got different queries, and otherwise you can see it on the repository in GitHub. And the same thing that I have mentioned for schedule goes for packs format. You just add the name of the pack, what you would have the queries, and on the query you would add the name of the pack, then the interval for the query, and then you also have an additional field which is OS query version, because you might have an infrastructure which is very fragmented and you have different versions of OS query installed. You might have a version which does not have the last or the latest tables that have been added to the other versions of OS query, but you have others. So, for example, in this case, the query would say execute this table only if it is in this OS query version.
What I mentioned before about the watchdog in OS query, if you launch this on OS query ID, you will get something on the watchdog, and what it's doing is looking, because necessarily OS query executes in a given system, so it doesn't request a CPU or groups. That's something you have to look into if you need to free some areas for other functions. But by default, the watchdog ensures that OS query never goes over the CPU or memory usage. It needs to extract information from the machines without affecting what is going on in the machines themselves. So if you don't configure this, the watchdog in OS query will restart the service. If for over 9 seconds, OS query has the system at over 60%. You could hash all the files that I have in my home, because you might find a large file and OS query might start working, and this will increase the CPU above 60% for more than 9 seconds. You can set this up manually. I want it to be less restrictive, for example, or I want it to be more restrictive. And that's the same with the allocated memory. If you do queries with a lot of information, until that information is sent, then it doesn't come out of the storage of OS query. There's a query that uses a lot of memory, then the process will do an analog of more than 100 megas. This will execute. If you use advanced OS query with a table of events, for example, you will probably want to move this up to 300 at least. You can get memory very cheaply, so that's fine. The shell for OS query I and ID, and I'm going to talk about the remote IP for OS query to manage and to work with the tools for OS control. This is a management service for the users. In this case, it's me, because it's an example. Here we have an indication of how this would work. This is the architecture and the machines for OS query. We have the status and result logs that are sent over the internet, if you choose to do so. It receives the configuration through the internet, if you wish to or not. And you end up with an TLS endpoint, which is the management server. And this basically distributes the OS query configuration. So this is a simplified diagram, because this is the most basic concept of machines using OS query. So this is how it would work with a centralized server. So what can we get out of this? You might say, I don't want to set up OS query to cause me issues using flags and certificates and so on, so that OS query talks to a server. So what can I get out of setting up OS query with a TLS endpoint? Each time OS query talks to the server and the logs are automatically sent, coming from the machine and stored, then you can use a concept called distributed queries. In this case, it's on-demand queries, the same ones that are executed from the machine itself, from the console. And the results are sent directly to the server. It's like having a distributed cell within the machines that are running. So for investigation, forensic investigation, investigation of incidents or internal use and so on, it's very useful. It's because it's like having a cell within that machine. It's a read-only query. It's encapsulated with all the capacities and security and performance of OS query. So the solutions that currently exist on the market for an endpoint TLS, some are for free and some are you have to pay for them. Osctrl is one of the first ones that came out, which is an IT management system. It's not very up-to-date at the moment. And Dormant was an interesting one. It was in Python. But they haven't done much maintenance on that for quite some time now. I put OS control in there several times so you don't miss it. I don't know if you know Live Ops. I don't know if you know Carbon Black. It used OS query logs. SGT is in serverless infrastructures from Amazon. And then some of the most well-known ones, which are commercial solutions like Aptix and Collide. Collide also has another version, but it's missing a few little pieces. So to implement an endpoint TLS, it's not very complicated, but you might say, oh, I'm not convinced with any of the current situations or the options that I have, and I want to do it in Cobalt. Then what you've got to do is to implement a handler. So you implement the handler to receive the requests, the post requests, to have them enroll in the machine. It receives another handler to distribute the configuration, another handler to receive the logs. They can be status, results, or query logs. And then you also have to implement some handlers that I'll show you in a moment for on-demand queries, for file carving, and so on. It's not really that complicated. The documentation for OS query is very well prepared, and you have it here on this URL. It can say what the format will be, what you should expect it to give you, the information you should expect to receive. And it's very easy to follow because the documentation is really well prepared. Either in flags or remote configuration, there are a number of values that you need to configure so that OS query can use a remote system. If you have a mutual TLS, then you need a client certificate or a password. You'll have to give the host name that TLS will use and the certificates for the servers if they are not in the machine keychain. I'd like to point out that the TLS endpoint is called that because OS query can only use TLS endpoint. It was done like that right from the beginning, so that there were no opportunities for logs that use a lot of sensitive information could go around on the network. So you can use OS query to use HTTP, but I don't recommend that because you'll have to make a number of modifications because it always tries to set up, you should always try to set up a stable configuration. That decision was taken to ensure that the configurations were always encrypted and so on. We've spoken about OS query I. I just need to check how much time I've got left. Is it 40 minutes? Yep. We've spoken about OS query I, OS query D, OS query D, there's the daemon where you configure programs, and the remote OS query tool, which is used for programming your own TLS. So now we're going to look at some of the implementation details and to present the OS control tool. It was liberated in September. There is some documentation available. It isn't actually complete yet. I've got to polish it a little bit. There was an introduction there available, but basically the idea behind it is here. If you have any questions later, then I'll put the information up. But you can also get in touch with me, no problem. Why did I write an endpoint, TLS endpoint, when I could have used something else, such as doing a login within the machine, using the flags or heavy forwarding? There were many, many different options for removing the logs from the machines. There's also chef or puppet options for distributing the different configurations. But the idea of using the TLS endpoint was the fact that there are certain things that on the existing solutions I wasn't convinced about because it would make you do something in a certain way, or it wasn't modular enough, or it didn't have the ability to support certain things. And I started writing this in 2016 when Aptix, for example, didn't exist as companies. And these companies were created using the OS query business model, but at the time they didn't exist. So at the time, there weren't many options for a tool of this kind. So writing one of these was because I was interested in particular in distributing the configuration. I wanted to build a change in the configuration. I wanted it to be as fast as possible. And now, none of the solutions that exist are able to deal with that. It's an extraction of files within the machines, and this concept is called file cards. It's an OS function that's not documented. You can extract files from documents, but you can't deal with them. If you go to those files, you can implement, and it works very well. And I'll show you this in a moment. And I really wanted to be able to have on-demand queries. I was also interested in having an open source solution that I could change as I wished. And at the time, there wasn't much else available. It needed to have different modules, and there were things that I weren't quite convinced with, but it wasn't sufficiently modular. and I also wanted it to be scalable. And this was particularly important, because when I had the first version of OS control internally, I spent around maybe 10 days looking to see if the configuration had been downloaded, and all of a sudden there were 15,000 machines all of a sudden, from 0 to 15,000. I didn't have enough capacity in my code. It wasn't a bad experience. Nothing broke. The service continued. And I thought, goodness me, that's a good thing that I wrote this, and now when I have issues, I know how to fix them, because there are many machines that have gone down. You don't know what's going wrong with them, and this is when you say, oh, well, I have to go in there and resolve that. So I wanted it to be modular and scalable, and it was equivalent to the performance of the TLS that was going to work with. So this is the diagram of the control of the components. There is one thing missing here that is implemented, but it's not documented, but it's in the repository. This diagram it looks a little bit crazy, but it's not complicated, but I'd like to point a couple of things out. And I'll probably point out a few more things as we go along. This looks like a kind of a crazy person diagram, but the TLS service is what stores and receives the logs and distributes the configuration. So they had the OS query nodes, is distributed through internet, is distributed through NGINX. It emits metrics, and the information is stored in the database. The main idea of this direct communication is that it's a critical point. So when you need to make changes, it needs to be balanced. Otherwise, the system will break and stop generating, and you'll lose visibility. So what you want to get from OS query, you will lose that. So the idea is that the logs should be sent to servers, whatever the type they are. It could be Splunk, Kafka, ELK, whatever. So this is a component of OS control. So this is OS control admin. Here you can see I've got internet here, but in the administration console, I don't put that in, because one of the reasons I wanted to get my own solution was that many of the systems that were being produced were distributed geographically, and I wanted the solution to be a one-stop shop solution. But CoreNet is basically laptops that people take around there, and there are thousands of people who have them. And so you can't wait until people are connected. So what I wanted was for the TL service to receive that and distribute the configurations of the internet. Meanwhile, the administration service could be over the internet, but in actual fact, the operator would send it over the internet. It could be SSO, VSAML, whatever you use for your internet applications. But in actual fact, the access would be through a VPN. The idea is to ensure that the communication through the administration and the TLS is done using the backend. And that's internally connected through a network, and it's the same with the metrics and so on. And you can use this information for whatever your purpose is. And take into account the critical information that you're working with. You don't want that to be available on the internet. So you have this console behind a VPN or other similar kind of systems. That's a little bit of a detail.
Aquí os lo voy a enseñar ahora mismo.
I'm going to show it to you right now. This is taken from Osctrl, and it's basically a web that shows the machines that you have configured, the UID, unique ID, and everything else. And the last component that I would like to mention is the command line in Osctrl. Usually, if you want to see something that you don't want to expose all the metadata that you have stored in your database, and sometimes you might even want to see it in bulk, or just integrate it with Slack, for example, or with anything that you want to do through Jira tickets. So you're not going to go directly into your backend system because you might make a mistake, and instead of writing system, you write delete. So really, we don't want to be fiddling with production systems like that, because it might wake you up on a Monday morning if you make a little mistake. So in order not to have to do that, I wrote the command console, which is basically an interface with the same functionality that the packages, the administration packages, give you, but it is very configurable, and it has in a very similar way as Osquery. So I'm going to show you a couple of things now, but lastly, I would like to mention that it is highly important to always emit metrics within your system, because usually when you have systems that are scalable, or when you have many systems, it is very important to know what's going on, and to be able to identify patterns within your graphs that give you information without having to go in depth into all the information. For example, here we have a metric graph that Osctrl deploys by default, and you configure it so that it starts generating it directly. And I think this is a capture of the same data, but for only 12 hours. But here you can see another snapshot for 7 days. And here you can see there have been changes, so you start seeing really patterns. So this is just to mention it, because sometimes we didn't realize, or because big data generates a lot of information and stuff, but sometimes just looking at this graph, the one at the bottom right, you see that there's a failure, but you don't know what's going on. But this is going to help you to see that on this day, between this and that time, something has happened, and then you can locate it. And obviously you can see very interesting things, such as when the employees in specific time zone go home and they stop logging because they shut down their computers. And now I'm going to show you the actual system, Osctrl, which is the same one that you have on GitHub. I still need to add a couple of things. So you have login. Can you see it at the back? Yeah, I'm going to zoom in because someone is saying that they can only see it so. Is it better now? Right. So basically, Osctrl, and I've been deploying it whilst Vicente was finishing his speech, and I have launched it, and I'm running it locally on this machine, and I have enrolled the actual system directly within Osctrl. So you can see here the metadata that have been stored in this system. You can see the rolling, all the information that has been sent, the decorators, everything that I have shown you before. The status are being sent, and the result logs we are getting are those that are configured. Here is where we configure the information. These flags here are the intervals at which the events for log configuration and queries are being done. Queries is on demand. And here we have the configuration as I showed you before, options, schedule, decorators. It's a very simple configuration. This query is executed every 60 seconds, and the logs are sent every 600 seconds. So because I don't have it configured, every 10 minutes it is being sent. Now I want to show you a couple of things now. Just a second, please. See, I'm going to put this on 70 seconds. Now, what happens now? I've saved it, and the machine I have configured it through this one-liner. And I'm going to show you, this is the script that is generated dynamically. This is not going to come out because I've done something for certificates, because otherwise Chrome gives me a lot of pain with signed certificates now. So this is the local machine, what you're seeing right now. Just so you see that this script is generated dynamically with the enrolling secret, which is a URL that you should not be able to guess. And then you can also configure the system so that this expires in a few hours. Say, for example, you want to have this expire, then it wouldn't work. See? So the idea is that those one-liners are used for enrolling machines on demand. And I'm going to show you how to do it. I'm going to lift a couple of virtual machines with different Linux flavors. You can see everything that I'm getting here. These are B-Grant machines, by the way. So I'm just going, I'm logged in as administrator, so I have access to everything to do with administration. I'm going to make a couple of changes here. Right. I'm going to refresh the environments to 60 seconds, and I'm going to refresh here to 60 as well. What I'm doing right now is to be able to show you the back mode, because I have a sudo cache. I haven't finished implementing read IS, so I have this right now. So I have changed the flags in this machine, but the flags that I have for this service that was pre-configured are the flags I had before. But now I want them to be faster. So I have the 300, 60, and 600 here. Because this is a local file, I will have to use a one-liner to change it. So I activate the command. The command is shell, by the way. It works on every Linux, Mac, and I have another one that is generated for PowerShell as well to enroll Windows systems. So we execute this here, and now we have an updated configuration. And you can see we have 70, 30, and so on. So now the machine has an accelerated configuration now. And what I'm going to show you is we're going to enroll more machines. I'm going to enroll a couple more machines, as I was saying, so you can see. I am actually creating, because I have a concept within the system that I call environments. So say, for example, I have an environment, which is the development environment, and you can also see the notes by platform, by the way. Say, for example, you are developing a master, you have a virtual machine that is enrolled in this environment. So how could I create a new environment now? You would go here to environment management, and you're going to call your new environment CyberCamp host name. It's 10.10.10.5. This is my machine's IP. And this is font Tizen. This is for the CCS. I've chosen this type because I'm working on a standard agent, which does not make me to run it as OS query. So say, for example, in an IoT environment, because it's a smaller architecture or something with limitations where OS query is not compilated for and could not run, then I am working on a standard agent that talks to OS control without needing to use OS query. So this is like an abstraction of OS query. It's a C2 for production systems. So what we would do is create the CyberCamp environment, and take into account that when you create your environment, if you don't create it with the command console, you would get the flags generated, but you would not get the certificate generated. So what we're going to do is we're going to copy the certificate from the one we have already created, which is the auto-signed certificate. And what we're going to do is say, okay, use the same certificate so that OS query can talk to the server. So I'll just copy it here, upload, and there we have the certificate configured. So we've got the flags. We're going to reactivate the enrolling commands. We've got machines running in the CyberCamp environment, and now we're going to activate these machines. So we launch this, and what's happening right now is that enrolling has detected that OS query is not installed. It's going to install it for the platform you have selected now. It could be OX or it could be Windows. It's lifting the service right now. And if you go back to the environment, you can see that this is the machine that we've just enrolled. We've enrolled it 13 seconds ago. It still doesn't have any status, only the configuration, because we had inputted it at the beginning. So you can see how easy it is to add machines that are running with OS query. And now we're going to do the same with all these other machines, which is follow the same process. Yes, there is a question. Yeah, this is configured so you can use the endpoint TLS that you're running. In this case, I have local machines, and what they're doing is sending logs to OS control, which is running on my laptop. So we're going to add here all the others. And basically what we're doing right now, I've got different machines, and we're going to see, because I've launched the service, so now we'll see different machines, see a Red Hat, two Ubuntu's, M218, this is a Trusting 14, and this is a CentOS, I think 7. Well, so what's happening right now is that these systems are receiving the configuration. We don't have a status log because the machine has just been enrolled, so it hasn't sent anything yet. So you don't have results yet. So because you haven't received these results, and we have the logs configured for every 60 seconds, we're going to this has only been there for 45 seconds, so we're going to wait a bit longer to see how the status logs are going to come in, because OS query is gathering them and sending them at the interval that we have configured it for. And then you can configure the scheduled queries that are going to be sent depending on the interval that you have chosen for the flags. Now, I think the default configuration that I use are these values because I have already tested them and they work well. So what I'm going to do is I'm going to update. Sorry, I made a little mistake because it's going to take a bit longer now, but this is what I'm doing right now, which is basically updating the flash file. And now we should have this applied, and we can have all the logs. So you can see we have a status here, so it is sending OS query logs to the distributed system, and the logs are giving you warnings and everything, so you see that there is an issue and you can detect it. So OS control installs by default the logs that go to the local database. If you have many machines, this is not a good idea because you would have to compact all the logs because it would generate a lot of information. So what I would recommend is, well, actually something that I'm working on right now is for this to show only the last 24 hours or 48 hours, depending on what you choose, of the logs that are locally being stored so that you can have everything that's been going on. This is only showing the last 6 hours of logs. But if you need to look at further information, then depending on the log that you have configured, be it Graylog, Kafka, Elasticsearch, or whatever, then you would get the data. Now, what else can I show you? Well, if you see here, no logs have been sent because I don't have any queries configured. So I'm going to configure something. I'm just going to change something here so I don't have to write it afterwards. And see that you have to check that JSON is valid, because if you make a mistake here, then the configuration is going, it's not going to work. The machine configuration, and then you would have to go back. Now, so we have set it to 60 seconds. If the JSON is not valid, then it tells you that there's failure. Let's ask another query. Let's send a system info query. So what I want to do is, when I store this here, this makes the change, and because this sends it to every client next time they check in, which I think it has been configured to 30 seconds. So this is going to start sending information about status, as you can see, publisher, etc. And you can start seeing the results. This is going to refresh every 60 seconds by default. So we're going to start getting results for the scheduled query, which is every 60 seconds with an display of 0. And so every 60 seconds we're going to get that information, and otherwise we could get 60 plus the interval. So we're going to be able to see it in a little while. So this is more or less what I wanted to show you. For example, on-demand queries. Say you want to check on Debian 9. You want to see the CPU's info. So you go to host, select info, and in this way you would have an on-demand query configured. The query is active. Progress means that it has been programmed. It hasn't been sent yet. So because it was created 13 seconds ago, as you can see here, so the query on demand sends the information every 60 seconds, I think, is the configuration that we have. So we will be able to see it very shortly. We can also have a file. So, for example, you want to get the /tc/password for this machine. So you've got environment, platform, ID. So I want to get that information. Now this has been completed. We can see that the file has been carved, that we can see the ID, at the different blocks, because you can configure it according to the size for the blocks that you want, what kind of block you want, and then you say, please download the file here. You go onto the command, this was cart files, the file, here it is. We're just going to move this here so that it doesn't destroy everything that I've been doing.
So now they're doing a tar. It's carved files. So this is the machine password. So it's very powerful in all the computers that you have in the system. In 2 minutes, I've shown you how it works, how Osctrl works. Maybe I can show you a couple more things for advanced users. The components, they have a TLS endpoint, the metrics, the backend, and so on. So the next component, which is in the repository and I've tested, but I haven't documented it, is the API for Osctrl. It allows you to expose all the data in the administration controls, but from an API. So what I was looking for with this component, you can do it to integrate it so that you don't have to do this more than once. So the administration, I've got it in Bootstrap, so I could link it to an interface or another reactive component to take the information from the API. And I could even have communication with a backend using WebSocket, and this would be even faster information. But one of the reasons for the API is for the relationship that it has with other projects. In this case, it's GoQuery. It was liberated a couple of weeks ago. What it does is to implement a distributed cell using Osquery through an API. It also uses another couple of things that have not been documented, which is an accelerated system and so on. If you're using an OS query in a specific way, you increase the interval. So instead of it being the seconds that you've configured, then it's a shorter interval. This hasn't been documented, but it's very good for research purposes. So a couple of things I wanted to show you. One important thing is that if you're going to use it, if you're going to use query or Osctrl, feedback, tests, issues, whatever you're interested in, everything is, we welcome everything. There's one for Osquery, one for Osctrl. You can go into those blogs, and I write things in there. I've got a couple of friends who use Osctrl in their businesses, and they add information in there when things are going well or so on. So feedback is always important and useful. You can use Twitter, and please do get in touch with me. Now, I've just got a few minutes left. I'd like to show you advanced OS query use. So if you now know how to use OS query and you know how to use your TLS endpoint, what's the next step? You could use OS querier to detect archives. Perhaps you have confidential files and you want to know when somebody is using them. You can use OS query for that. I can show it to you quickly. I already have a configuration here for OS query. I use file events through the API, and it returns the data to you. I'm going to configure this through Osctrl, and you'll see how powerful it can be for monitoring purposes. I'll show you a case for if you have a Docker container, for example, in which you have files and where the database is configured, and you have some credentials that you don't want to filter. So in this particular case, I'm going to show you some queries. So this is the query that I sent to the machine. So in the last 10 minutes, we're going to do a little test with the file interval. Here we can configure a table of events. A table of events is advanced users because it's very complex, but I'm just going to show you how powerful it is. It takes the information from the file events and it determines the routes that I want to monitor. It can be binary R files or bin or SBin, and you want to go in and have a look at what has been going on there. For example, it would be the demo CyberCamp in this particular case, because I want to show you an example. In this particular case, we're talking about Osctrl, because we're talking about machine development, but basically it's all about looking at how powerful this function is on Osctrl, OS query. So this is an Osctrl machine. So the configuration was set up 8 seconds, so it probably hasn't had a chance to do anything yet. So it probably is configured for every 30 seconds. So let's just wait a moment until the configuration has been loaded. We'll see when it is loaded. When we see an event, when an event has been activated, when the file events have been activated. And this will give you an alert on the status logs. It will receive the configuration. Let's see if the configuration has actually been sent. So the logs won't be sent until another 60 seconds. It's received uptime and accelerated in 30 seconds. And here we have a little bit of extra information. Here you have a number of options. Here we just have one machine that's being configured, so it's going to send you the alert. But when you use events, then you're going to get rid of events that have expired, because events expire automatically. Otherwise, you'll have many, many events over time. So you need to know when you're extracting those logs. And if you're going to do a query with many different logs, you may get a lot of different events. So you have to keep that in mind. Let me show you then how this works in terms of the events and event files for monitoring purposes. The file we're monitoring is the file with the credentials for the database, the control database. You may have credentials that nobody can use because you want a safe storage system and you want to know if an engineer is accessing that. So it's /opt/occontrol/config/db.json. This is the configuration of the database. And we need the configuration of the system. There might be a system that can only be accessed by a given machine. It depends on your protocols and your policies in terms of permission to access the production systems. We have done the CAT, we've accessed the file, and since we have the events configured so we can detect accesses to those files, the next time OS query sends data, if everything works properly and things go well here this afternoon, then we will see that access to that file by a user, and we can see how that comes up within the results. So it says here 15 seconds. No, it's not looking good. It said last result 3 minutes ago. Again, it says 30 seconds here. This is the trouble with the demos when you're doing live demos. It's executed the file events just 40 seconds ago. Let's see if the expiry is very short. We don't have results, but I don't know why. Let me have a look. I think I know what has gone on. We have a log in the storage for logs, and that was what was causing us some trouble. So let's cheat here a little bit. We've lifted the service. We should be able to see it here. We should see that has restarted in the status logs. Let's have a look at the results. We have the status and the results log. We have the machine that is sending the logs. Let me see if I can work out what's going on. I'm afraid the demonstration didn't work as I would have liked it to. I think it's doing event expiry, and I'm going to remove that so that it does not remove them. It's set up for 30 seconds here, that's fine. Let's let it configure, and I'll continue with the presentation, then we'll come back to this. Okay, yes, now we have it. We've sent it a few times, so perhaps actually it got a bit stuck there. So here you can see the events from the events file with the category that we put in, the path that we put in, and the A time, the C time, and so on. So now we have a large number of events. I didn't realize that I had the event expire 1 there, and when the event expiry is in 1, each time there is a query to the table events, it expires everything that has been stored. So this is why the intervals are important. because if the log hasn't been sent, it's going to go into expiry, and you'll get rid of that. So this is why this part is important. So it's important to see when somebody has accessed a file. That's the point. I can't go into other details of advanced OS query. We have file integrity monitoring, writing. I've showed you the configuration. I suggest that you play with this a little bit, using a machine that you can do that with, because it does generate a lot of information. So I only use the advanced users in certain situations. Unless you have a small tier of machines, then actually before you play around with events, you need to have a lot of agility in doing configurations and events. But as you can see, it's a very powerful tool. Here we have the Osctrl wiki, and there's a lot of documentation there. It's very useful. And the same for Yara rules. You can use OS query to do searches in certain paths for Yara rules. It can be a malicious binary or an indicator of an attack or similar. You can have a table of events and use them a little bit carefully, as I was saying. And OS query extensions. You can extend the configuration of OS query if you just have information from a thrift handler. Then you can access information from tables that you're interested in. It's a very powerful tool, but it needs to have performance as their priority. So you might cause a bit of a bottleneck depending on the information that you're dealing with. Each extension is executed in a different process. It's simple to create the extension, and you can extend OS query for the commands. But on the other hand, you do lose a little bit of the essence of OS query. There's a repository, and people who do a lot with OS query put information in there. There is information about analysis of fireware and a lot of very useful and powerful information there, and that's for advanced users. So, do we have any questions?
¿No hay preguntas? Bueno.
No questions. Okay, so Osquery documentation is available on the wiki. It's very well written, very well documented. The best thing, if you need to look at, is the code. The best thing is to go and look at the code, and some of OSQuery has not been documented. And obviously, there's the website for OSQuery. We have the repository, the scheme of the tables, and so on. And Osctrl, the site for that, is where you have the documentation, and the repositories where you have all the information on what I'm working on. Now there are more and more people using it, and so there's more and more information. I do put this information on Twitter and so on when I put in new versions. So that's all for today. Thank you very much for being here this afternoon, especially those who have waited until the end. I understand that it's not a subject for this late hour. So if you have any questions, please get in touch with me through Twitter or Slack. You can see me here at CyberCamp. Thank you for inviting me here today.